Hello, welcome to lecture 35 of game theory. This is the second lecture of the 11th week. We are in the middle of mathematically analyzing a mathematical example of principal agent problem, the moral hazard. And, you just review the previous lecture. Then there is a principal and agent. There are three outcomes, x1, x2, x3. There can be two effort level, EH, EL, high effort, low effort. And high effort, the cost would be 600 and low effort would be 0 and the reservation utility would be 400. Okay, you get it. And then I told you we are going to analyze the two cases where question number one, ideal case, where we assume ideally or unrealistically, that the principal can observe the effort level of the agent, which means the principal can enforce something like, agent, if your effort level is not high, then I'm not gonna pay you anything, something like that. So virtually he can directly enforce the agent to work hard. Would he? We'll see. And then the principal cannot observe the effort level of the agent, which is a realistic case, non-ideal but realistic. We are going to do that and compare them. So today's class would be heavily involved with many calculations. If you remember, you must have learned Lagrangian in mathematics for economists. It's basically maximization with a constraint, like you can see here. We are going to talk about the subgame perfect equilibrium. Why this is subgame, I explained, but I explain again. Let's say it's an ideal case, which means the EH is observable and verifiable, more importantly. So basically, the principal can say, oh, unless your effort level EH is achieved, which means if your effort level is not EH, it's EL, low effort, I'm not going to pay you anything, something like that. Okay, so the principal want to maximize the profit. Let's look at this. So we are assuming that the principal is basically enforcing EH, so no problem for the agent to do EH. Agent will not do EL. To tell you the truth, in this case where the principal, in this unrealistic case where the principal can observe the effort level of the agent and the effort level is EH, high effort level, what can the agent do? I mean, if from the agent point of view, he cannot go back to EL, then he will get like a miserable wage. Or, so that's a choice, but then if you do EL and get a miserable wage, you don't want to do that. More realistically, what the agent can do is, when the principal suggested this wage level, the agent may say, oh, I have a freedom of occupation. I cannot work for you because you want me to do EH, but your wage is too low, so I quit the job. I'll go to another company. I'll quit working for the 7-Eleven convenience store. I'll go for the CU or GS25 because they pay me more. Or I work for the delivery service or something. Okay? So that is what this means. Okay, let's look at the second line first. U hat is the reservation utility. Unless you give me more than equal to my reservation utility, the agent, so this is agent statement, I'm gonna quit. Whatever you give me should be bigger than my reservation utility. What is this? The utility from X1. So W1 is the wage when the result X1, in our example, 1 million happens. That happens with the probability P1H. P1H probability when effort level is high, the X1 happens. So this is expected utility for X1. And P2 is the probability for X to happen when the effort level is high. Then for X2, you would get W2 as a wage. Likewise, P3H is the probability that X3 happens, in our case 9 million when effort is high. And this is, and we already know P3H is half, P2H, P1H is a quarter. Okay, so this is expected utility from the wage minus, we know that there is a cost for high effort level, 600 in our case, minus 600. This is the net utility for the agent when he accepts this wage suggested by principal and exert a high effort level. That should be bigger than the reservation utility. If it is the other way, the reservation utility bigger, this is smaller than reservation utility, he quits, he never works. So even though the EH's observable principle has a mighty power, one thing the principle has to satisfy the agent is this condition in order to hold on to the agent, because agent would quit and he cannot have business anymore. So this is the condition to hold on to. We say participation condition, for the reason that in order to make the agent to participate, this condition should be satisfied. So the principal has to satisfy this condition, then the principal Tom should maximize the profit. What is the profit? Profit is the profit minus wage. Like the net profit would be like that. So the X1 is the profit, general profit, minus W1. W1 is wage when the result is X1. So this is the net profit for the case when X1 happens. And this is the probability for X1 to happen when the effort level is high. This is for X2, same thing. This is for net profit for X3. So the principal want to maximize this profit. Of course, he want the X1, X2, X3 be as big as possible, W1, W2, W3 be as small as possible. However, the W1, W2, W3 cannot be smaller forever, because this participation constraint, the whatever utility, net utility the agent gets should be bigger than the reservation utility. So, understand? One might be confused that how EH is assumed to be here, because it's observable, and when the condition, the implicit condition is unless it's EH, if it's EL, I'm not going to pay you anything. W1, W2, W3 would be 0. Then it is better for the consumer to work here. Okay. Okay. This is, as I said, subgame perfect equilibrium, because first the wage would be suggested by principal. Principal moves first. Then the agent here decides whether to quit the job or work for the principal. Okay. Of course, if it is not ideal case, there is another thing. So here T1, the first period, the W1, W2, W3 is suggested. Second period, the agent decide work or quit. It's the realistic case. There's another thing. The agent should decide whether work hard or work lazy. So EH or EL. should be decided. So in any way, the first principal decides, second agent decide. That is this game. And when this happens, we can apply backward induction. Whenever the principal decide W1, W2, W3, it would be dumb of him if he does not consider what the agent would do under that wage system. Okay? That's why we call it subgame perfect equilibrium. Let's solve this. You remember Lagrangian? Lagrangian is when you maximize this with this constraint. Lagrangian put this constraint into this objective function together. So if you look at that, this is the profit. This is P1H, P2H, P3H. This is X1, X2, X3. So this is exactly this. Okay? We just put the number there. And the next thing is the constraint. This is P1H, P2H, P3H, and this is cost of high effort. This is reservation utility U hat. And lambda in front of all this, that is Lagrangian characteristics. So the mathematician Lagrangian said, don't worry about it. When you maximize this with this constraint, just put the parenthesis here and put lambda in front of it, and you differentiate this and set it 0. Then you will get the answer. So let's trust Lagrangian. Once again, the objective function, profit, the constraint in front of it, lambda. Okay? So if you, what do we differentiate with? This is the wage. The strategy for principal is W1, W2, W3. That's the strategy that the principal can choose. These three values. On the other hand, in this game, the agent choice strategy is work or quit. Okay, so differentiate the Lagrangian with W1, W2, W3. You calculate 0, you calculate 0, you calculate 0. Okay, I hope you know root W1. If you differentiate that, that is going to be minus 1 over 2 root, not minus, 1 over 2 root W1. Okay, please check on that because root W1 is W1 powered by 1 over 2. If you differentiate that, 1 over 2 jumps out and 1 over 2 become minus 1 over 2. That's why you got here. Okay, just go back to your calculus notebook, high school days or first year freshman days. You know that if you differentiate this L with W1, you will get this. W1, 1 minus 4 here. There's only two W1s, W1 here, W1 here. So only first W1, second W1, 0, 0, 0. Then you will realize that W1, W2, W3 are equal. Root W1 here should be something like lambda over 2. So all these are lambda over 2, I think. So they should be same. Whatever lambda is, W1 is lambda over 2, W2 is lambda over 2, W3 is lambda over 2. Okay? So if they are same, what can we see? We use the fact that they are same in here. If you look at here, W1, W2, W3 are same. P1H, P2H, P3H together, it's 1. So all this would be just W1, root W1, minus 600 should be bigger than or equal to 400. Root W1 should be bigger than or equal to 1000. But then, you want to minimize the wage, so it should be 1000. So root W1 is 1000. That means W1, W2, W3 are 1 million. when you put 1 million here, W1, W2, W3, we don't have to worry about this lambda part because constraint. The upper part, first line is the profit. If you put it here, what you get, the profit when the effort level is high is 4.75 million. Okay, I mean, you have to calculate this. And maybe you may be confused first 1 or 2 times, but I think you will get it. And hope that you are accustomed to it. Okay? We are not going to have an exam for this semester. However, there's an assignment, and I really think you should be able to calculate this. Okay? I mean, it's one thing to know the intuition, but without calculation, what's the point of learning game theory? And even though it may look difficult, you can do it. It's not that difficult. Okay? Promise me. So, the result is W and W3 are 1 million and the profit is 4.75 million. What if it's observable ideal case and the principal want EL? Why does he? But anyway, from principal's point of view, what would be my profit if I enforce EH? We calculated that is 4.75 million. And he also compare what would be my profit if it's EL. If you think, what's the point? Always EH is high. Not really, because when you have a lower effort, you don't have to give him so much payment. For example, the Yonsei University president think about, I'm going to make Professor Han work hard. That means Professor Han would demand more money. Okay? He want me to teach now. I have to teach only 2 courses. But then if the president asked me to teach 5 courses, I said, okay, but you have to give me like 3 times more wage because I will be so tired. Otherwise, I'm not going to teach 5 courses. I quit. I go to other university, something like that. So the wage would increase as well as the profit when the EL become EH. Therefore, we have to check whether EL is the profit might be bigger than the H or not. Here, this and this. Here, one thing, the same thing as before. One thing different is the cost of effort of EH is 600, but cost of low effort we assume 0. That's why the 600 is gone. Okay? And why there is nothing here? Because effort level is low. I mean, I forgot. It's not gone. The constraint is now the net utility. Net utility should be only bigger than you had the reservation utility. So as long as this is bigger than 400, so this I didn't write down, but here it's P1L, P2L, P3L, and this is 0 and this is 400. From there, we have this. Okay? So this is P1L, P2L, P3L. P3L means the probability that X3 happens when effort level is low. Okay? So this is the constraint. If you differentiate this, once again, W1 is here and only here, and would it be this? Would it be this? 0? Would it be this? 0? Once again, W1 equals lambda over 2, W2 equals lambda over 2, W3 is lambda over 2. As a result, W1, W2, W3 are equal, and they should satisfy this W1, W2, W3 are equal, half, quarter, quarter. So this is 1. So this whole thing is W1 minus 400. So this whole thing, W1 should be bigger than or equal to 400. And why not giving the minimum wage? So it is 0.16 million. 400, 400. 160,000, that is 0.16 million. So now, compared to the wage previous case high effort 1 million, the wage considerably decreased, like 1 against 0.16. Okay, like 1/8. So the wage can be considerably low. That is why the government officer's wage is considerably lower than the private company's wage. And the profit would be, this is pi L, I'm sorry. This profit when the effort is low is, if you calculate it, put it here, 0.16, 0.16, 0.16, then you will get 3.59. I hope it's right, but according to my calculation, 3.59 million. What can we conclude from here? Once again, pi L, the low effort level profit would be 3.59. The high effort level profit is 4.75. So which one will you choose? The high effort level. Okay? That's why in ideal case, the high effort level would be chosen. Okay, too much calculation maybe? Hope that you can sit down and enjoy and think about why this happens. I'm going to explain more in the following lecture. And this is a little bit short lecture. However, we did a lot of calculations, so I'm going to stop the lecture 34 right here, and we are going to continue in lecture 36, the rest of the calculation. Thank you.